Alright, so we're going to take a look at something that's a little bit less interesting about functions, but there are three different types of functions, well, two different types of functions, and one that would be both. Excuse me. Alright, so we have injective functions, also known as one-to-one. That's a function such that every element in x, alright, every element in x, so this one for instance, whoops, trying to make a line here. Every element in x relates to a different element of y. So 5 relates to 4, then 8 cannot also relate to 4. It would still be a function, but it would not be one-to-one. So that'll have to relate to 8, and this will have to relate to something else like 5, and that'll have to relate to something else like 2. Alright, so every element in x relates to a different element of y. Let's take a look at an example. We look at this function. Every x has a unique y, so negative 4 goes down here to negative 9, and 0 goes to 0, and 4 goes to what looks like 6, but they're unique. There's no repeated y values. Unlike in a parabola, where some x's actually have the same y value, such as when x is negative 1, we get a y of 1, and when x is 1, we also get a y of 1, so the same y occurs. So you can determine if something is onto using what's called the horizontal line test. This fails, but if we go back to the previous graph, it actually does not fail the horizontal line test. It hits exactly once. So this is not one-to-one. Alright, so let's take a look at surjective, which is a little different. A surjective, or onto function, is a function such that every element in the range relates to a single element in the domain. So here we're kind of going to go backwards. We're going to make sure that every element in the range is covered. So 4 has to relate to something, 8 has to relate to something, so does 2, so does 5, and so does 1. So every element in the range has to be covered. That's why it's called onto. Everything is covered. Alright, so let's take a look at an example of the graph. This would be one that is onto. If this function continued, I don't think I drew it all the way up, but if it went all the way up, it actually covers all values on the y-axis. So that's all y's in this case. And since every y value has been covered, this was onto. Let's take a look at one that's different, or not onto. In this case, you'll notice that there are no negative y values at all, so it doesn't cover all of the range here. Actually, this would be called the codomain. The codomain is all possible y values in our medium. So in this small circle, there are only 5 of them, so they're all covered. Now, along the y-axis here, there are positive and negative numbers, but these negative numbers are not covered. So this function is onto if it were related only to positive numbers, but not if it relates to all real numbers, because the negative numbers are not covered. So not all y values are covered. Alright, so let's take a look at a bijection, or bijective function. Okay, so a bijective function is one-to-one and onto. So every x has a different y, and every y is covered. The best example of that would be a line. Okay, because a line, every x hits exactly one y, and every y has exactly one x. Alright, I hope that covers everything. It's pretty, they all sound similar, and they can be kind of confusing, but if you can remember a few things, that would help. Y, all y is covered. For onto, all y values are covered, that's surjective, and for one-to-one, every x only has one y. So repeated y's would remove it from being an injective function.